Today we are going to discuss about the I/O ports and their internal circuit configuration and how are we going to program to be as an input port as well as the output port. There are four, as we know very clearly that there are four ports are named used in 8051, port P0, P1, P2 and P3, and each of those ports are consisting of 8 bits. Out of the 4 ports, 3 ports are bidirectional, that is multi-purpose, and 1 port, which is P1, is of unidirectional, that means only one operation can be able to be performed, where our multitasking operations are to be performed. So P1, when we say P1, it can able to perform either as an input port, nor it can act as an output port. If we deciding this P1 to be act as an output port, then we will be writing the CPU to the external pin. If P1 is going to be represented as an input port, when we say input port, it is going to read the pin data into the CPU bus. That is possible in case of I/O port. How does it possible? With respect to the circuit diagram. Let me straight away go to the structure, how the structure will look like. There is a D flip-flop. So before we go to know the circuit diagram, certain terminologies you should know. This is a fetch, followed by this is a D flip-flop. So this D flip-flop, or this is a transistor, and this is a D flip-flop. The D flip-flop is nothing but a data flip-flop. Whatever you give as an input, that will appears in the queue, and the complement will be produced in the Q bar, and that output you are feeding to a transistor. For a normal transistor to get into the operating condition, the junction of these two terminals, emitter collector in case of NPN, here in case of gate source voltage should be equal or greater than or equal to 0.6. If then the transistor will be into the active mode. To emphasize that, we'll decide whether it is going to perform the read operation or the write operation. That will decide by this read latch as well as the read pin. And based on these structural representation of the port P1, we are now going to write or to study the internal hardware structure of the I/O pins. And TB here represent here as tri-state buffer. So we have a logic 1, state 1, state 0, and there is a high impedance state. So as there are 3 states are there, they will be termed it as tri-state buffer. Hardware structure of I/O pin. So when we say a D latch, it is used for writing into the latch. So tri-state buffer is controlled by read pin, and here it is controlled by read latch. We do have a transistor with a M1 gate, gate 0 if it is for open, gate 1 if it is for close. That will decide based on the D flip-flop output. Input, output and tri-state, and the tri-state, the third state will be always higher. That you can see in the subsequent below diagram. Whereas your input and output, it decides whether you need high or low, whatever it may be, just like a buffer. That means whatever you gave it as an input, it will be appear at the output here. Now the question comes, are we going to write or are we going to read which is going to be performed in port P1? Okay, so let me imagine this is the architectural diagram. We have a write latch, we have a read pin, we have a read latch, followed by we have this. Now when we are going to write one to a particular pin, what does this will happen? D flip-flop, D is a input 1. So obviously Q will be of the particular flip-flop will be made as 1. And because if it is 1, we could able to see that the input to the tri-state buffer will be termed it as 1. Output also will be made as 1. If the output is 1, the third state will be default to the high impedance state. So this is no problem, it is going to perform read operation. Followed by, when you come back to the output, which is nothing but 0, so it will not get a sufficient voltage. So whatever you give in the VCC will appear. So the output pin will be equal to 1. So this is what we are going to see that writing, how are we going to write the output particular pin of the port is made as 1. Similarly, you can also make the particular writing 0 to the output pin. So that time you can write 0 to the pin. So D flip-flop input is 0, so this is 0. Obviously this will becomes 1. You get a sufficient voltage. So whatever you gave in the VCC will drain down. So you will not be able to get the logic high output of the output in. So you will be getting an output 0. This is what writing value 0 that appears in the port output port of port P1. So we have a programmable view of writing this. Move A, 55, which is nothing but this one. Then we are moving PL port 1 to the accumulator. From accumulator we are moving to port P1. And then we are complementing it. What do you mean for the term complementing it? That is T flip-flop. Okay. We are checking the complement of it and then we will describe the operation of this. Reading the input pin versus the port latch. So when reading, there are two possibilities are normally extendable. So one is whether are you going to read from the input pin or from the input latch. Okay, so these are some of the examples which will demonstrate whether it belongs to read latch or we call them it is an input pin. Reading high at the input pin. So when it is 1, we will be having it as 1. 0, this will not be get over, so we will be getting output pin equal to 1. So if this output pin is equal to 1, there is a feedback path is coming in tri-state buffer, which in turn gives you the output is 1, and this also the output is 1. So this is what reading the particular pin at the high. Writing in the sense it tries to see that the output pin. Reading in the sense from the output device we are going to read something by 10 terminal device. Similarly, reading low. So when this will get low, whenever you try to give 1 to a particular pin. So read this is the output is 1. Q bar will be 0, and because of this the transistor will not drive. So if it is not drive, go the output and partial will be go to the signal. And this is a programmatical view to represent whether it is from read port or writing something into the port P1. And then we are moving into the port P1, and then we will get the data what is there in the port P0, and then we will be just seeing to that send the data to P2. And this is a repeated operation, is just each and every port is just transferring a data and try to check whether you are reading the data from the sequence of operation or not. So we cannot use all the instructions for accessing the input port. there are only specific instructions you can use. One is move, jump on byte, and there is one more instruction, move. Except all these instructions, you cannot able to perform read operations. This is just a continuation. Reading a particular latch, and then we do have a pin called modify write features, and this write feature will try to perform the combination of three actions in a single instruction. What is the three actions? Either it can read as a latch report, performs the operation and modifying the latch, and subsequently we do have other sections writing to the pin and this is one. So either of the way you can able to do it. Either if you are just moving the direct data and then performing complement, or you can perform it through XOR operation also. Okay, so this is the sequence of IO port and the circuit.